So welcome back to Analysis and Design of Algorithm class. We'll continue our discussions on assignment problems. So what is this assignment problem? So yesterday I have explained briefly. Once again I am going to find that video. So assignment problem is nothing but we have m number of persons here. Okay, m number of persons who are laborers who are ready to work, and we have n number of jobs. Means the jobs what has to be accomplished. Then the task, the objective of this particular problem is that find the best optimized combination in such a way that the cost of assigning m number of n number of jobs to m number of persons, n number of jobs to m number of persons in such a way that the total cost will be always minimum. Okay, so you have to always reduce the cost of assigning the n number of jobs to m number of persons. Okay. So now if you consider this table, you have job 1, you have job 2, job 3 and job 4. And you have person 1, you have person 2, you have person 3 and person 4. So there are 4 persons and there are 4 jobs. So what is the interpretation of this table? So 9. So this 9 means what? So 9 is the cost of assigning job 1 to person 1. Okay. And if you take this 2, it is nothing but the cost is 2 of assigning job 2 to person 1. Similarly, if you take this one, so this one means the job 3 will be assigned to person. So that is the meaning. So now if you write the same thing in a matrix format, so 9, 6, 5, then we have 7 over here. This is 6. This is 9 and 4. Okay. So this is the matrix format of representation of the assignment problem. So now the first combination is what we have taken is 1 to 4, 3. I'm going to share the PDF. See here, I hope the PDF is visible for you people. So we are choosing a different combination here. The first combination is 1, 2, 3, 4. This is the first combination. Second combination is 1, 2, 4, 3. So this is the, by keeping 1, 2 constant, I am going to change the third element and fourth element. So that is the combination. Now what I am going to do, I am going to take another combination here. So this is 1. Now you take 2 is over now. 1, 3, 1, 3, 2, 4. Find out the cost. Find out the cost. Then after this, so we have 1, 3, 2, 4 is over. Now similarly another combination is 1, 3, 4, 2 is another combination. So once again find out the cost for this combination. Now 1, 3 combination is over. Now you take 1, 4 combination. So that is 1, 4, 2, 3. Find out the cost. So then you take 1, 4, 3, 2. There is another combination. And once again find out the cost. So can you give me the values for this cost? So what about 1, 2, 4, 3? What is the cost? How much for this value?
18.
Mustafa? Alright.
Eighteen, sir.
Can you tell me this combination, that is 1, 2, 4, 3, how much it will yields?
30.
30. So the value is 30. Next we have 1, 3, 2, 4. What is the value?
4.
Mustafa?
24.
24. Then we have 1, 3, 4. What is the cost?
26.
26. Similarly, if you go for the combination 1, 4, 2, 3,
33.
33. Then 1, 4, 3, 2,
23.
23. So we have these values now here. So first value is 18, 30, 24, 26, 33, 23. So among all these, which one is the optimal? Because all these are the basic feasible solution. So basic feasible solution 1, basic feasible solution 2, basic feasible solution 3, basic feasible solution 4, basic feasible solution 5 and 6. Among all 6 combinations, which one is the optimal?
1, 2, 3, 4.
1, 2, 3, 4 will be the optimal. So this value. So this combination is optimal because the cost is minimum. The cost is minimum. So whatever the value means, if you assign job 1 to person 1, and if you assign job 2 to person 2, and if you assign job 3 to person 3, and if you assign job 4 to person 4, the total cost, assignment cost or expenditure will be minimum. So that is the interpretation. So this is the different combinations. So this is the exhaustive search mechanism. But actually this problem can be solved by using another straightforward approach, so called as a Hungarian method. So have you ಬರ್ಕೊಂಡಿದ್ದೀರಾ? Shall I rub this?
Yes, sir.
Now, the same problem we can solve by this problem, that is assignment problem can solve by using Hungarian method. I think you people, if you have studied operation research in your BCA, have you studied what? Have you people studied operation research? Okay, no problem. So now the next thing is the same problem we can solve using Hungarian method. So we can solve this problem by using Hungarian method. How this Hungarian method is going to work? Let us find out. So first you write the matrix in the form of table. Okay. So assign the cost here 9, 2, 7, 8. Then we have 6, 4, 3, 7. And we have 5, 8, 1, 8, 7, 6, 9, 4. Okay, so if you consider this, okay, So these are called as persons, and these values, the columns called as jobs. So how to find out the optimized combination of which provides minimum cost of assigning these n number of jobs to m number of persons. So how to achieve this? Let us find out. First, you scan the entire row. Hungarian method, how it works. You scan the entire row by one, row two, row three, row four. You first scan the first row one, and identify the smallest element with respect to each column. With respect to each column, identify the smallest element. If you consider row one, which is the smallest element over there?
2.
So 2 will be the smallest element. Okay. Okay. Now you cannot take this column. You cannot take this column for further process. Okay. Next, you go for the next. This is over now. First row is over. Now you go for the second row. To identify the smallest element by ignoring this particular thing because it is already assigned. So what is the smallest value?
3.
3. So you assign the make the allocation here. Okay. Now this column you cannot take for further reference. Okay. So now you go to this. This is over now. You go to the row 3 now. That is third row. Now you try to find out the smallest element.
5.
You have to go for 5 because one is already assigned with respect to this particular column. We cannot take this column. So that is why we cannot take 1. So you have to go for 5. Make the allocation over here. Okay. So now this column we cannot take in the future. So what remains now? So only 4 remains because this is already locked. So we cannot make any allocation. So only 1 is left. So with all this, what is the cost? If you according to Hungarian method, what is the cost? 2
14.
plus 3 plus 5 plus 4. So the value becomes around
14.
14 actually, isn't it? So now this 14 is also less when compared to 18, isn't it? How's
Yes, sir.
So this is the best method, that is the Hungarian method. But in exhaustive search method, we cannot use the Hungarian method. We have to go for different combinations because the exhaustive search mechanism itself tells that Hungarian, I mean, no, it's a combinatorial type of problems. Okay, so understood? Assignment problem ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
So this is all about exhaustive search. So now we'll continue with divide and conquer. So now we continue our discussions with divide and conquer. So now you can see over here, okay, Hungarian method. So Hungarian method is by using, you can find out still much more optimal value. Okay. So divide and conquer. Yes, so this is the PPT of approach. Which I have a logic. The word divide and conquer. So I think you people have something familiarity about this divide and rule policy. Do you have any idea about divide and rule policy? Have you heard about this word? This word comes from history. Divide and rule. You know, people when there is a in around the British have made, okay, they came here for a commercial purpose. They started to rule us to various kingdoms, even though they have made a rigorous amount of retaliation. But what they have done, they have divided the different kingdoms and they have started to rule. Means they have utilized some of the loopholes, isn't it? Some of the drawbacks of of some of the things, the political aspects, what can happen inside, and that is why they have conquered so many kingdoms. Means they have made a lot of clashes among the internal kingdoms, which made them to exploit the situation. So that is what. So a problem can be divided into sub-problems. If you have a problem, you cannot solve this a problem on your own. So what you are going to do, you have to divide the problem into so many smaller instances, or what we can say sub-problems. Then you find out the solution for these sub-problems. Then once you identify the solution for the sub-problems, you integrate them. So if you integrate them, so you are going to get the actual solution. So this is called as a divide and conquer. Okay. The most well-known algorithm and design strategy, that is the divide instance of problems into two or more smaller instances. Means we divide an instance, problem way, we are going to divide it into two or more smaller problems or instances and solve the smaller instances recursively. Solve the problems, that is smaller sub-problems recursively. Obtain the solution to original instance by combining. Once you identify the solution for the sub-problems, you integrate, you combine them. Integration and summation or combining. So this is the diagrammatic representation of a divide and conquer. You have a problem, isn't it? A problem of size n. You divide this problem into sub-problems. That is of size, since it is a problem of size n, if you divide it by 2, you are going to get two sub-problems of size n by 2 and another sub-problem of size n by 2. Then you find out the solution for this sub-problem 1. Once again, you find out the solution for this sub-problem 2. Then you combine the solution of these two sub-problems. You will get a solution for the original problem. So this is the divide and conquer. So the example for this divide and conquer techniques are merge sort, quick sort, tree traversals, binary search, multiplication of large integers, multiplications, that is matrix multiplication, that is in particularly we can call passing matrix multiplication, all this. So this is the another concept, that is the divide and conquer. Okay, so the input size of this particular technique, okay, is defined by n to the power of k. Input size is defined as n is n is equals to, or what we can say 2 is equals to n to the power of k. So here this can be once again solved by using Master's theorem. So what is this Master's theorem? It is going to tell three inequalities. Okay, so based on a function p of n, which is equals to some constant a into p of n of n divided by b plus f of n. So this, where this f of n belongs to eta of n to the power of d. Okay, where d is always greater than or equal to 0. If a is less than b to the power of d, means if whatever the constant a, if it is smaller than some exponent of d of b, then in this category the function p of n, it belongs to eta of n to the power of d. On the other hand, if a is equals to b to the power of d, then p of n belongs to theta of nd log n. Suppose if a is greater than inequality, then p of n belongs to theta of n whole to the power of log a base b. So these are some of the uh, results which can hold both. Okay, some example has been given here. If you compare these two, you are going to get A as a 4 and B as 2. Okay, substitute the values and try to find out whether this function belongs to whether theta of n to the power of d or n to the power of d log n or n to the power of log a base 2. So this classification of a function, so based on the exponent and the constant values, is called as Master's theorem. Okay? So we have a Master's theorem in the previous classes also. Okay, so that is based on asymptotic notations, but this is based on the divide and conquer recurrence relations. And see a small example here. See, we have a function here. So input size n is always defined as 2 to the power of k. Means input size will be always contains even number of numbers because 2 to the power of k. Suppose 2 to the power of 0. It means anything to the power of 0 is 1. So if 2 to the power of 1 means 2. 2 to the power of 4 because k is greater than or equal to 0. So, so if you give k is equals to 1, 2, k is equals to 2 means 2 square, that is 4. And if k is equals to 3, 2 to the power of 3 means 8. And if k is equals to 4 means 2 to the power of 4, that is 16. Means input size will be defined always as a even number. So now if you consider this function, a of n is equals to 2 into n divided by 2 plus 1. If you compare this with the standard t of n function, a will be taken as 2. A will be taken as 2 if you compare here. See here. T of n is equals to a into n by b. So this is a coefficient a, this is b. Okay. So if you compare these two functions here, so 2 will be taken as a and b will be taken as 2. So a is equals to 2, b is equals to 2, and b is equals to 0. Okay. So because so according to this, so there is no any values has been given. Since a is greater than or greater than b to the power of d, because 2 is greater than b, b to the power of d, b to the power of d, anything to the power of 0 is 1. So that is why 2 is greater than 1. So a is greater than b, d. So this is the third category. So theta of log a base b will be taken. So that is theta of n. Because log a is log a value is 2 and b value, substitute the value of a and b. So log 2 base 2 is 1. So theta of n, anything to the power of 1 is n. So theta of n. So much. Now we will discuss some of the problems which comes under divide and conquer technique. Under this, the first type of problem is a merge sort. So the name itself tells merge means what we are going to do. We are going to divide. We are going to split an array into two equal parts. Then once we are going to divide the entire array into two equal parts, first we sort the two parts. First part, second part. Then once you sort them, you have to combine them. You have to merge them, and that becomes a sorted array. Okay. The process has been given over here. Split array. Consider an array A of 0 to n minus 1. So 0 is the starting position, and n minus 1 will be the last, that is the index, into about two equal parts. Means divide the array. For example, if you consider an array of size 8, you divide first 4 elements and the rest of the 4 elements into two equal regions, and make copies of each half in arrays B and C. Okay. Sort arrays B and C recursively. Separately sort both the first part and the second part recursively. Then merge sorted arrays B and C into array. Means you combine the B and C arrays into U. And repeat the following until no elements remain in one of the arrays. Means you continue to repeat this process until all the elements the remaining unprocessed if you are not processing to part, then you so the index indicating the unprocessed portion. Now you can get the next element present in the unprocessed region. Next. Unprocessed. So this is the pseudo representation of a merge sort. The merge sort A is the array, 0 is the starting position, n minus 1 is the end position. Sorts array A into A of 0 to n minus 1 by recursive merge sort. Then input is the array and output is also an array, that is ascending non-decreasing ascending array. If n is greater than 1 means whatever the value what you have given, the value is greater than 1 means array contains some values and copy A of 0 to n minus 2 minus 1. This is the first half. 0 to n minus 2 minus 1 represents first half. You copy these values to the B array. Then this is the second half, that is n minus 2 to n minus 1 to C array. Next, you recursively sort the B array, merge sort from 0 to n minus 2 minus 1, merge sort 0 to n minus 2 minus 1. Then once you completely sort both B and C, you combine them into A, that is merge using the function merge. You combine B and C array into A. It's the pseudocode for merge process. Okay? So this is the merges two sorted arrays into a sorted array. So input of course two equal equal portions of the array, that is B and C. So and both of them need to be sorted. Okay, this process will just combine the sorted arrays. So output is a sorted array. So we have indexes here I, J, and K. So while I is less than P and J less than or equal to less than Q. So if the first element of B array is less than C of I, J, then you first store the Bth position into K position. Otherwise, you store C element into array. You will increment the index K and I and J. Then if I is equals to P, means suppose if you have reached the end of the array, then the copy entire unprocessed elements into A as it is. So this is the merge process. So this is the diagrammatic representation of a merge sort. So you can see the array over here. It contains 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements are present over there. So 8, 3, 2, 9 is the first half. 7, 1, 5, or 5, 4 is the second half. So we are going to divide them into two equal half. First half and half. Once again, you recursively divide this array into two equal halves, that is 8, 3 and 2, 9, 7, 1 and 5, 4. Then once again, you still divide this because this process of division will continue until and unless unique element, only one single element is present in the array. So when you divide this, you are going to get a single element 8 and 3, 2 and 9, 7 and 1, 5 and 4. Now what you have to do, you have to sort now. So 3 and 8, you have to compare them. Okay, so among them 3 is the smaller, 8 is greater. So first 3 will come, then 8 will come. So among 2 and 9, so it will be kept as it is because 2 is smaller than 9. Among 7 and 1, 7 is small, 1 is smaller, so that is why 1 will be taken first, then 7 will be taken. Then we have 5, 4, 4 will be taken before 5 because 4 is smaller than 5. So once again, you perform the same process with respect to what we have completed in the above step with respect to 3, 8 and 2, 9. when you compare 3, 8 and 2, 9, 2 will be the smaller, first 2 will be taken, then 3 will be the smaller, 3 will be taken, then 8 and 9. And if you compare these two, this set of values, you have 1 will be the smaller, then 4, then you have 5, and 7. Once again, now you compare these two 4 values with respect to 2 equal half. We have 1 will be the smaller, next, so that is the 1 will be taken. Then we have 2, then we have 3, 4, 5, 7, 8, 9. So this process will generate a sorted array. So this is the best illustration of a sorted, merge sorted example using divide and conquer. So this is the analysis of merge sort. So these are the log n factorial 2, which is approximately equal to n log n base 2 minus 1.44 n. So almost that is theta log n about general logic. So theta of n log n, because logarithmic function will hold good for divide and conquer technique. So n log n. So n for this n is for merging the functions, and log n for dividing the array. Okay, so that is why combination of n into log n will be taken as the analysis of merge sort. This is quicksort. So about quicksort, I am going to explain it in the next class. So if you have any queries, you can ask the students. I request all of you to give your attendance in the chat box. Okay, dear students, if you have any queries, you can ask. So I'm going to stop today's class. I'm going to stop here. So thank you so much for joining my class and analysis and design of algorithms. If you have any queries, you can ask. Otherwise, we shall wind up. No doubts? Shall we stop there? Okay,
Yes, sir.
thank you so much for joining my class. Please take care of yourself. Thank you so much.